We don't.
Yeah, you want to start?
Yes. Shall we start now?
Yeah.
Must we? Okay.
It's 2 o'clock.
Okay. I'm still waiting for Mirja, but I guess she'll come. So hello, everybody. You're here. You made it. This is the Alto show, Alto working group session here at IETF. My name is Jan Sedov. This is Vijay Gopani. We're chairing this working group. So let's move on. Next slide. So we assume you all know the node well. Basically, this is about IPR. So if you haven't read it, read it. And if you are aware of any IPR and you want to know if you need to mention this, just check this carefully, and then maybe also let us know if you have any issues. So just a brief overview of what's basically the status of the working group. We haven't met physically at IETF meetings since IETF 93 in Prague. There was, however, a virtual interim meeting in October, and Vijay, thank you again for steering that meeting, where we made some progress. Specifically, we did this meeting because we didn't have time to meet physically in the Yokohama meeting. So as chairs, we discussed how we see the working group. We think we are behind schedule, but we are mostly on track. And we just discussed this also with our new area director, Mirja, who's hopefully going to appear any minute now, that, you know, we are behind schedule, but most IETF working groups are, but we are making good progress. And for all the chartered working group items or milestones, we have actually documents, and some of them are in working group last call right now. So we are doing pretty good. We also have plenty of new work and several new use cases, and we're happy that we have several presentations on that today. So there's some new, fresh work coming into the working group. So I hand over to Vijay to present the drafts in motion. But is there anyone bashing the agenda? Any? 1, 2, 3? No. Okay. By the way, we're passing around the blue sheets. Please make sure you sign the blue sheets, right? Is there a blue sheet in this aisle too? Okay, thanks. Okay, Vijay, go ahead.
All right, thanks. So thank you, Sebastian, for Jabber, and Sabine and Lyle for the minutes. So there's a few drafts that you can see up there that we're going to be discussing today. The deployment draft has been gone, is out of the working group. It's with IESG. It's been through various IESG reviews, the ops reviews, the GenArt, etc. There was an issue raised on third-party IPR, but that turned out to be a no-op, essentially, because there was no IPR being put on the draft itself. The draft was used as a reference in some patent applications. So the authors of those patent applications have said that there is no encumberment with respect to IPR, and the draft can move forward. So I expect it to now move shortly after this towards the RFC editor's queue. Multicost was in working group last call. This has been reviewed by Wang and Richard. Thank you very much for that. When Sabine presents this, I'd like her to close any open issues that arose from working group last call discussion, and we'd like to wrap it up soon and move it out as well. Incremental updates was also under working group last call, and that ended on 18 July. It was also reviewed by a few people, and again, thanks to you guys. But I think we need one more in-depth review of this draft. The reviews that we have so far are excellent, but I think we need to go a little layer deeper into this. So Jan and I have asked Sebastian to review this draft, and he has agreed to do so. As soon as this review comes on the list, we'll then figure out what to do with the draft to move it ahead. Cost calendar is a independent draft. Call for adoption was issued on the working group list. There have been no comments so far. The draft is fairly mature. Sabine has been talking about it for a number of IETFs now. And this goes towards a charter item. So when she presents, Sabine, when you present, please try to see if we can adopt it, have a hum here to adopt it as working group item. Anything we do here with respect to humming and adoption will be ratified on the list, of course. In the absence of any other drafts that go towards that charter item, there's a good possibility that the working group will adopt this. Cross-domain discovery is another draft that we'd like to adopt today. Now, most of you may be aware of this, but let's just point it out that when we adopt a draft for working group item, essentially that doesn't say that the draft is done and ready to move out of the working group. All that says is that this is a potential draft that goes towards a charter item. In the absence of any other drafts, then the lone draft is adopted as a working group item, or if there's multiple drafts, then we have a consensus process to see what goes towards one or more drafts that goes toward the working group item. So we like to, again, put this forward. So Sebastian, when you discuss this, please drive it forward to completion. And if we hum here for adoption, it'll be ratified again on the mailing list.
So regarding milestones, so these are the milestones from the current charter, and yeah, we're behind time. Okay, I'll try to hurry. So this is just an overview of the milestones and where we're at. We are behind schedule, so we discussed in red. You see some new milestones that Vijay and I proposed, and we actually discussed already with Mirja, our new area director, and she seems fine with it. So we're probably going to update the agenda. The milestone delivery dates to what you see here in red. I don't want to go into detail here because we're already behind schedule, but you can see that for most of, actually for all of the chartered items, we have documents that have been well discussed. So some of them are actually in working group last call. We have some that are towards working group item, but even for the other ones, we have actually mature documents that have been presented multiple times. So we think we are actually quite on track here. Again, this has been discussed with our new area director, and we think we're doing quite well here. Another thing that actually came up during this IETF meeting, and I'm happy that Kevin is here, who's chairing the CDNI working group. I've presented this here already, I think at least once in this working group. We have a proposal in the CDNI working group for a new Alto service. And what we did in CDNI, and actually this is already in the RFC editor queue, is a new JSON object for CDNI footprint and capabilities advertisement interface, FCI. So that's done. And in the CDNI working group, we have agreed, and again, I presented this here as that we were going to have a new Alto service, and you can see here the new media type that we're going to specify there. And we want now this new Alto, this new Alto service to be specified in a merger of currently two drafts that Kevin and I have, because basically a lot of the draft that a lot of the content from Kevin's draft got into the document that's now in the RFC editor queue. So we want to merge these two documents. And actually, Kevin and I, as chairs, actually discussed this, and we also discussed it with our area directors. We would like to move this remaining item to the Alto working group. And the reason is, and I'm pointing also now at the authors of the SSE document and so forth, that we are actually defining a new Alto service to transport this JSON object that has already been done. So the JSON object, of course, is very CDNI, semantically specific, but that is finished. So this new Alto service, I think, is really the right place, is the Alto working group to discuss this. For that, we will need to add a new milestone to the Alto working group, and that needs consensus from the working group. We've already talked to area directors, and as chairs, we agreed, Kevin, right? So the chairs of CDNI and Alto think this is a good thing to do. The area directors agreed, but Mirja, as area director, reminded us that the working group needs to have consensus on this. Since we have a packed agenda, we're not going to discuss this today, but I just wanted to inform the working group we take this to the list. So probably in the next couple of hours or days, I'll ask the working group if they are fine with adding a new milestone. This is very well within the charter, because the charter says we're working on Alto extensions and new use cases, and this is a perfect example of that. So we don't need to re-charter. So we're going to ask for working group consensus. Any comments right now to this? No. Okay. So right. So we're moving on. So basically, we're going to the first presentation, which is, if I look at the agenda, programmable NFV SDN orchestration with Alto. Lyle. Correct? So, yeah, we do. I have to remind everybody, we do have a really packed agenda, and we want everyone to get their time. So please keep within your allocated time slot, which is 10 minutes, Lyle. Yeah, that's the way it is.
We got to get moving. All right, next slide, please. So actually, just run on to the next slide. So for those of you that may not have familiarity with NFV, I'm highlighting some of the parts here, and I'm calling out a few. But this is kind of the base Etsy model with a few pieces pulled out. We have our orchestration layer really instantiating virtual network functions that are managed by the VNF manager. The VNF or application in most cases is typically managed by an element manager as well. That may also be a network manager. We don't really worry about how that's actually organized. in general. Down to the bottom right here, we have the Virtual Infrastructure Manager, or VIM, and there's lots of pieces in this. It's managing all the different life cycles, all the different virtual infrastructure, but we pulled out in this particular diagram the SDN controller, and you'll see why here in a few minutes. But that's typically a part of the overall VIM. We kind of use it as a catch-all for many things. And in this particular example for today's discussion, we've also pulled out the SDN switch away from the compute, storage, and everything else. And I'll talk a little bit about what's up in the data store in there. When we have a VNF, we have a VNF descriptor, something that describes what's actually happening. We have templates, and we'll have different things like constraints and resources consumed, and that plays into some of our orchestration capabilities. So next slide, please. So when we actually looked at how we would actually get all of this data in, and I'll explain why here in a minute, we looked at potential sources and sinks. And as you know, back in October during the interim meeting, we actually talked about the application of CDN self-organization and the application of virtual EPC. What we didn't talk about was the fact that in our designs at Sprint, in our work, those are actually VNFs. And we didn't talk about the fact that many of them actually sit over an infrastructure like this. And part of our work, what we discovered was the sources and sinks are pretty straightforward. Our two main sources of information are the SDN controller. It's essentially providing all the tenant information that is typically invisible of most of the rest of the NFV infrastructure. And also the NFVO. What we found was we looked at many other places. Did we get it from the VNF, VNFM, Element Manager? Element Manager is a good source, but typically in general, especially when we talk about orchestration and how we might enable for that, if it's so important that we needed to get the data to the orchestrator, the NFVO, then it's also just as important that that path is very fast and probably the fastest path in the system. And so that meant that the NFVO was a good source for this type of information rather than trying to force many, many interfaces. And so it ended up being a much easier way for us to look at the controller and the NFVO as the sources. And then, of course, you know, as we were just talking about, we had CDNI. We also then had the EPC. So VNFs are also clients. And we go into detail in the paper on some of the flows. The other thing to note is the map service is very much delegated in the IRD at the orchestrator to the SDN controller. And this is just reflective of the fact that the tenant information isn't the real information from the network provider's point of view. That comes from the SDN controller. So next slide. So what we learned out of all of this was the thing that I didn't talk about in the upper left, which is the aggregator. So that was just one VIM, one instance. What we've learned as we've actually done research and are moving toward deployment as an operator with NFV is that if we have really dense computing racks, we typically only get about 8 to 12 racks of equipment before we have to kind of cut and call that a pod or essentially a VIM cluster. And so what that really means is our ratio is basically about 8 to 12 racks per SDN controller. So if you look at a site with 1,200 racks, you're talking about 100 SDN controller sources. If those are Alto servers, you're clearly not going to start having your orchestrators query 100 different controllers for a single site. We have many, many sites across the nation. This just isn't going to scale. So aggregation is a must. I've talked about it before in some of the IDs, but this is just once again the fact that reality is sinking in. There is no one controller, there is no one orchestrator. And if we're actually going to make this work at a practical scale for an operator, especially a nationwide operator of any kind, aggregation's got to be considered. So when we look at this, we view that as the first and foremost requirement to making anything work with respect to NFV. So next slide, please. So we then moved this into the orchestration system and started looking at, okay, we've actually done a couple of implementations where CDNI is self-organizing, where the EPC is self-organizing. What can we do for the orchestrator itself? And that's actually the primary focus of this work. Just quickly, right, if you're not familiar, we get basically a service description as a VNF forwarding graph, VNF-FG. The graph is then cut up by the orchestrator, and then we try to figure out what parts can actually be hosted by one or more VIMs. Hopefully, if we can compute that very quickly, we can then assign or request to the VIMs those resources. Hopefully, we can get those resources. Nothing's guaranteed in life. And then what we can do is then reconstruct all the links in between all of our VIM communications, our SDN and such. We can actually render the VNF forwarding graph over our network. What's the Vim doing? Technically, it's bin packing, you know, and you can get into a great P versus MP debate, which apparently we're only limited to 10 minutes today. So if we'd have 15, we could probably host a little bit of that because it only takes a few minutes to go through. But we'll move on. Next slide. So when we actually look at the algorithm, and this is in here, we have a very simple algorithm that actually runs across this. So in the first step, we take that VNF FG and at the orchestrator, cut it up into parts. So these are proper subgraphs, and we refer to those as S1 through SN, 5 here in our example. And as we started laying this out, we realized we had two kinds of data. We had the resources you consume. So whether you're a low, medium, if you're familiar with flavors, but your CPU and resources. We then also have the performance constraints. And so those are actually part of that VNF description information, what's needed to instantiate. And so that's all within the orchestrator. Now, the other data then is how do we match this up with what a potential Vim can do, a Vim candidate. So this is the second matrix that we have, and it's comprised of two pieces of information. The actual resources the Vim has in terms of the compute, the number of flavors, CPU, those sort of things. And those can be represented a number of ways, but for today's purposes, a matrix was good enough for us. And we also found then that typically the constraints that were related with latency and everything else look very familiar to someone who's with Alto. They look like metrics and they look like endpoint costs. And so the cost service makes a lot of sense to us. So the way we think of it is the resources from the Vim come from the Vim. It may be interesting, and I would urge people to do future work to look and see if it can make sense via Alto's map or endpoint properties. We still believe right now, for our purposes and our work, we just put it between the Vim and the Vims and the orchestrators. And the rest of it comes from Alto quite nicely using the graph we showed before. Simple subtraction here, any negative row. We call this the candidate suitability matrix. We throw out anybody that's out of that. Next slide. And then we do your standard weighting because I have administrators and they think they know how to weight things and they think they can rate things because they're better than machines. So they throw in their specific weight vector. They get some ranked solutions, and then they let it go. So this weighting vector gives the administrators a little bit of a feeling that they have some control over the system, and eventually we might have the computer automate that. But right now, I've got to convince my operations guys that it's, you know, they have a little skin in the game. So this is the simple algorithm. So next slide. So when we actually looked at the Vim data matrix, we looked at the performance data and we actually ran into 3 specific problems with respect to data being provided by Alto. So the first one is use case 1. So the data is actually present in, say, an SDN controller. Maybe it's actually an open daylight controller. It does have an Alto server, but for whatever reason, whether it's initial config or anything else, we didn't supply the data. So this is typical. If we have a stock image of an SDN controller and we're bringing it up as a VNF, it will be configured to apply a certain best guess of what the data is, and it may be collecting others. So what we want to do here is, once again, the on-demand measurements that we talked about before, where basically if we do enough queries, it would adjust its filtering information and push it. So this is a new use case for Alto. This is really an implication of a dynamic filter capability with on-demand, so that we don't have to send everything, but we basically send our best guess at the initial configuration, and then based upon the request, send and expand and contract the filters as necessary. The second use case I'll talk a little bit more about on the next slide, but not yet, is basically what if the data is not there at all? And I'll skip that for a second. And the last one is, what if it's a new metric? So this is really interesting. In VNFs, this is all metadata. So if a VNF descriptor, a type, a template comes up, and it's describing a new metric we've never seen before, but it is a metric that can be computed and provided, what do we do here? This really is an implication of providing a new metric for Alto. That's a new use case and a new service. That's something we haven't talked about or looked at before. And I think the more interesting item there is there's an opportunity then to do things like downloading code, if you're familiar with Open Daylight, downloading another plugin, doing something dynamic, moving that metric from maybe being an available state to an active state. So giving metrics a concept of state in the IRD, and then supplying that data. So that then allows us to actually expand the columns in the matrix and the performance side and contract them as necessary. But once again, not a difficult use case, but a new use case for Alto. So next slide. Okay, so the use case 2 overview. So as we're familiar, if we're doing aggregation, this is essentially a miss. So in aggregation design, it hits both servers, serving both endpoints. At this point, if we had the data, we would supply it using on-demand measurement. But what we're looking at here is basically adding to this a very simple query where the Alto server X can actually figure out where endpoint 2 is and get a new property. We call it the measurement initiator, a URI, and then invoke some new communication. We describe a little bit about what that communication could be and how that could be managed and some other things. But that's really outside of the Alto scope. That's something we'll have to contemplate further. But this is essentially how we see that being provided. So next slide. Communication with the Vim, I'll kind of leave it here. We basically send top row is what we request to instantiate. The second row is what the Vim said it could provide. The third row and fourth row is the programmable side of our VIMs. So the upper bounds and lower bounds to basically notify from the Vim back up to the orchestrator if something happens. So it's very simple. It's a very simple protocol and it works pretty well, very easy to implement. Next slide. So this is the proposed system and I'll leave you to read it, but it's a very simple system, multi-Vim, multi-orchestrator, very simple with matrix computation. I'm sure there's many improvements that can be made. But once again, we urge you to read it. And then I think the last slide. So the question is for the group, and it's a very simple question, and I'll take it offline, is this document was meant really more of a white paper to get this information out and get some feedback and improvements, but it has 4 requirements. And so if the group is interested, I can turn it more into a prescriptive application with implications and requirements for Alto document, if that's desired. And that's it. I think I'm at time.
Yes. So I think clearly this is some new work that Lyle is bringing to the Alto working group. How to move around this work, how to structure it is something that we'll have to decide at a later stage. But I think if once we are done with the current deliverables, then we have a set of new items and new deliverables. This could kind of point the way to what those new deliverables and items might be. So if you have any comments, quick comments.
Oops. Okay, Richard, a very quick question from Yale. I found, for example, a part of, you do propose quite a few very interesting features. For example, one feature I'm very interested in would be this on-demand measurements and metrics. Do you think there will be a very high level? Do you think there will be, for example, implementation, or you really foresee, for example, will become protocol? For example, maybe a signaling between, for example, from your last use case 2, might become a signaling between server 1 and server 2, or so.
I think measurement initiation would become something like signaling between server 1, server 2, but the on-demand measurement use case 1, use case 3, definitely via Alto. And keep in mind, right, the genesis of kind of that server-to-server communication for measurement initiation would be stimulated by Alto. But the actual measure-to-measure negotiation rate change, at this moment, right, and it's just our first pass, I don't see it being Alto, but I can be totally wrong.
Andy Veach. So I like this a lot. There's a lot of background work probably that goes on in translating things like policies and all the measurements and all this stuff into the representation you have. Is that something that people would consider to be work that happens Alto, or are you looking at this possibly coordinating with T's or other people? If I'm thinking just purely Alto, I always think the interface and really what's up. And I'm thinking specifically the implementation in Open Daylight. There's a lot of stuff. Or is that TBD? Someone else solves that for you?
Actually, I'll tell you right now, I cheat. I rely on the Open Daylight plugin. So maybe Richard and his team can respond to that.
Okay, I'm sorry, but we got to move on. But I see Diego. Yeah, I know this is very interesting, and I was just going to say, I always thought Alto would play a big role in SDN controllers and provisioning information to the controller and stuff. And so I think this is very useful work, and I'm happy that we're having this discussion. So I can just encourage the working group to keep this discussion going on the mailing list. And for sure, so what we see as chairs is definitely interested in this, and we should move this forward and continue the work and keep this discussion on. Right. So, and maybe in a next or a couple of next ITFs, we have more agenda time for this once our chartered items are, a couple of them are off the list.
Absolutely.
Right.
All right.
Okay.
Thank you. Excellent.
So I just want to take the time also to welcome Mirja, our new area director. So this is the first, she's there. If you don't know her, be nice to her. She's our boss. So be very nice to her. And we thank her for her wisdom that she's already provided us with. So it's the first IETF where we actually meet physically with Alto, and she's actually our area director. So I just wanted to take the time. Yeah, so next up is Sabine, talking about the cost drafts. We are a bit behind schedule. I think with the multi-cost, Sabine, probably if you can make it quick, because we are having a working class call, and I think this is going rather smoothly, so I don't think we need much time for it, but of course, summarize the discussion. Okay.
Okay, so next slide, please. So just this is we got some working group feedback since the last version, and thank you to the working group. So next slide, please. So this is just, well, I will give then a digest on what we have updated. So we have extended the section on constraints test because the feedback led us to think that there is a number of clarifications necessary, and in particular we needed to update the design so as to ensure that fields like testable cost type names can live together with the presence of a constraint attribute. And we also updated the input, the parameter section according to this. And we have started a version 3 upon comments that arrived after the release of the version 2. So next slide, please. So basically, this is I leave you to read it. This is how we extended the explanations on the constraints tests. And well, basically the design was as follows. We wanted to avoid creating new media types, and we also wanted to ensure backwards legacy with compatibility with legacy Alto clients. So next slide, please. So here is an expression of the legacy Alto compatible design principle, and we used it for the Alto calendar as well. So the design principle is that a legacy Alto client, by this I mean an Alto client that only understands 7285 RFC. So this legacy Alto client must be able to send legacy requests to the multi-cost Alto server and receive responses as specified in this RFC 7285. So this is how, this is why we have updated the testable cost type name design. So now we are sure that a legacy Alto client can use a multi-cost server just without problems. So the next slide, please. We added also text on constraints and or constraints to explain the difference, because what we added basically is a constraint can include several cost type, several metrics, and also have a combination not only of, it's not only an AND combination, but it's also an OR combination. So just know that there will be additional updates because we found a little errors. So next slide, please. So we also added an IPv6 example. And next slide, please. So the next steps will be that we will finalize version 3 with respect to remaining working group feedback. And we had a recent feedback about the responses. There was a concern. So I think I hope I have just answered your question, because what we may need to clarify is that we didn't see any problem, because a legacy client will send a legacy request. So it will never ask for multiple cost type. Otherwise, it's a multi-cost aware client. So it will always see that field cost type. It will never see a field called multi-cost type. And so we believe that the design principle is just that legacy client should be able to interact with a multi-cost aware server without even being aware that it is a multi-cost server. So thank you.
You want to say? So as chairs, I mean, we are very happy that this is progressing, and we're happy for the feedback and the comments. So this was a working group last call, and we think this was a successful working group last call. There have been comments. So Sabine, as soon as you finalize the newest version with addressing hopefully all the comments you just stayed on the mailing list, then maybe we'll give people a couple of days to comment. But we see this mostly done, right? So we are very happy with this. Another chartered item that we can almost cross off the list. Yeah, Richard.
Okay, Richard. And quick question. Of course, number one would be, I guess I did send a few comments. I guess they are after the last call. So do they still count, or maybe because I didn't miss the deadline to send?
No, all comments count, even they come after last
Okay.
call. No problem.
That's very generous.
No, I mean, especially since now there's going to be a new version, and obviously we're not going to send that right away to the ISG. We're going to post it on the list and have a couple more days, but we're not going to have an official working class call again because these were minor comments.
Right. Remember, change process is built into IETF. So.
Okay. Yeah, great. Yeah, because my main concern would be, and even though I do buy Sabine's point that, for example, the multicast types would be only received by the client who understand the semantics. But of course, I guess my main concern would be then it's going to break the media type, which is auto cost type, which cost map, which supposed to must include the cost type. So somehow some kind of placeholder must be added into it to make it compatible. Otherwise, we're breaking the media type. I think that's my main concern. I really hope that can be addressed, even though it can be dummy one and a placeholder. At least that would ensure, for example, the media type is constant. We don't have to really go to auto cost type V2, for example.
Yeah, so this is what I suggested, I guess, this last day, if it's really a concern, but again, we should discuss it on the list, but I'm not sure it's a concern, but because if we want, as far as RFC 7285 is concerned, we don't see a problem because it will receive the response as has been specified. So if it's really a concern to the working group, we may consider adding a dummy, as you say, cost type, and adding to that a multi-cost type that will only be seen by multi-cost clients.
Yeah, but thank you. I think we moved this discussion to the list.
There is ways forward, so let's take that to the list in any case. And
can I make a second very quick comment? And given that now we have multicast, and now we have a very quote unquote interesting, sophisticated, for example, constraints. And I wonder, for example, do we get closer and closer, for example, to like a SQL query language and select where, and essentially where specify the whole where clause? And this moment we have and we have or right in both. And if that's the case, do we want to really say, look, now essentially we just have different encoding for the generic and select SQL language filter capability or not?
Well, yeah, this is foreseeable. I mean, I think this is something that we should discuss on the list as well. So definitely there would be room to extend that design and to extend the application and to come up with other guesses about how we can use and exploit this extension of constraints. But yes, that's a...
So Sabine, please drive this to completion on the list, especially with the last couple of open items. And whether or not we take up the and constraint, if that's going to increase the scope, then understand that we'll have to, the document will have to be in the working group for a longer time. So all those discussions we can take on the list for sure. Okay.
Okay, so now to the cost calendar. So next slide. So, well, in a nutshell, the Alto calendar allows deciding where, not only where to connect, but also when. So this is one of the working group charter items. So basically, what is a calendar? It's just an array of time-dependent values. And this array is provided together with attributes, helping the client to understand what is in the array. So the length of the array, how many intervals I have, when does it start? So this allows delay tolerant applications to schedule their connections and optimize the time for data transfers. So it allows Alto clients to schedule their calendar requests with an optional feature that tells them, well, what you get as an information, actually, this will be repeated for the 3 or 4 next time intervals, so you don't need to request again. So this is optional, but this may be useful for highly dynamic networks, for example, where you really want to save your transaction time on the wire data exchange. This is applicable, of course, to time-sensitive Alto metrics, and the Alto service, the applicable Alto service, the filtered cost map. If you want to have a regular full cost map, you just use a filtered cost map request with empty source and destination endpoints. And this is applicable for the endpoint cost map as well. So next slide, please. So again, the design drivers were backwards compatibility with legacy clients and multi-cost Alto as well. So the calendar, we did not create any media types. Instead, we created new information resources, and those information resources include the descriptive attributes on how to understand a calendar. Again, it does not introduce a new cost mode because there was a big headache on how to provide calendars with quantities or with information in string mode, for example. So we could avoid this difficulty. And so again, we did not introduce new media types, and we made it compatible with any cost mode. So next slide, please. So
I mean, let me suggest this. I don't want to go through all the features of this because this
has been presented multiple times.
Yeah, it has been presented multiple times. In the interest of time, what I would like to do is to see how many people actually read this version. Two.
How many people have read previous versions of the document and know what cost calendar is actually about? So, yeah.
Okay, so I think there's enough people here that can at least, we can take a hum to see if we adopt this as a working group item.
Right. And before we do that, let me remind the working group, we have chartered milestone for cost extensions. What Sabine presented just before this is, of course, such an extension, but this is another one that is quite useful. So we as chairs think this is useful. So, but the working group, of course, needs to decide if we want such an extension. And again, before we take the hum, a reminder, working group item doesn't mean this is finished or perfect or done. It just means does the working group want such an approach as a cost extension to the Alto protocol. That's what it means. And of course, it means this is a reasonable approach of doing it, of course. Sure. Okay.
So let's take a hum. We have a charter item that says, one of the things we need to do is to figure out when to connect, and the calendaring draft does that. There is no other drafts that propose an alternative method. So based on that, all the people who think we should adopt this particular draft as a deliverable to the charter item, please hum. All those who think we shouldn't, please hum. Okay, I think this is fairly clear. Please.
This is Sebastian, also humming for Wendy Room and Greg Bernstein on Jabber.
Excellent. So I think the decision is pretty clear. Now, Sabine, what we'd like to have you do is to maybe recast this as a working group document, and the discussion continues. By no means, does it end, of course. So.
Yeah.
okay, so
we bought ourselves.
No, but I mean, we're sorry that we have to cut you off. So we are encouraging, of course, the working group, now that it is a working group item, to go through these comments and have this detailed discussion on the list. But in the interest of time, we would like to spend our time today more on the other stuff that is still on the agenda, right, Vijay?
Right.
Sorry, but. So next is Alto for blockchain.
Stefan.
Right.
You're already 5 minutes in your.
So we're having all the hypes in the Alto working group, SDN, NFV, and now blockchain, right?
So yeah, Stefan Hommes, University of Luxembourg. I will present today our draft that is using Alto and showing for the application scenario of a blockchain network. Next slide. So I will just give a brief overview about blockchain. So basically, blockchain is a distributed ledger technology, meaning there is no central authority, and such a ledger is basically distributed over a certain set of peers, meaning each peer stores the complete blockchain, and the blockchain has basically two important items. It's the transaction and the block. The transaction is, if we look into the Bitcoin network, basically payment that was sent from a sender to a receiver, and in order to make such a payment, to confirm basically such a payment needs to be validated and included into a block. From a network point of view, it is of course important that the population of transactions and blocks is done very fast. So meaning we have a large number of such transactions and blocks, but a low throughput. And of course, it is important to synchronize the whole peers with each other. Okay, so we think Alto could be interesting for two things. First of all, for the peer selection itself, but also for the information propagation. If we look at the Bitcoin network, we see at the moment we have basically, for the peer selection, we have a fixed number of DNS servers that is hard-coded into the client, meaning a peer that joins the network contacts the DNS client, receives the list of peers, and starts a connection. So our idea was basically to use Alto in order to get a better recommendation on what peers to connect. In a typical blockchain network, we have different kind of roles, meaning the communication between those nodes might have other criteria. That was the reason why we think we can use Alto, because we can apply different kind of metrics for each kind of role. We put everything, like we put the Alto client basically in a resource directory, so that each node has not to provide their own client and contact the Alto server to avoid that it creates even more traffic, but we will just use one client in a resource directory that will afterwards give us a list of the most interesting peers to connect. Another aspect is the information propagation itself. So, for instance, in the Bitcoin network, the blocks and transactions are not populated through the network, but it is just populated the availability of a new node. Meaning, if a transaction has been executed on some wallet, it will be confirmed by each node, and afterwards it will tell us the availability of such a transaction. And our idea was basically either to use Alto in order to come up with another kind of population mechanism, because the broadcasting is of course using a lot of resources, especially since due to the broadcast there are peers that receive multiple messages from multiple peers. So that would be one way to use Alto in order to build basically some kind of graph that avoids the multicast. Another idea would be that we basically keep the system, but in case a node wants to request a transaction or block, Alto will give guidance to this. Okay, so we believe the benefits for blockchain could be, first of all, in order to reduce the traffic by giving a better kind of recommendation to the peers on where to get blocks and transactions. The second advantage could be that basically with different kind of roles, Alto provides this kind of metrics that can be used that gives some freedom to a blockchain service provider to decide how the node should behave. And we are also thinking now for the future about what kind of metrics might be interesting to add to Alto that could be interesting for the blockchain. But for the moment, we have not seen any metric that is interesting to us. Last part, it's something that is again related to the Bitcoin network. Basically, as I said in the beginning, it's important that we have some kind of synchronization in the network, because otherwise we have the situation where we have multiple chains, because there might be minor nodes that found a block and start building based on this block. And in order to avoid this, there is a system already built in Bitcoin to resolve such situations. So it's not in general a problem, because Bitcoin was designed with this in mind. But anyway, forks are not something that we really want, because it's a waste of resources in the end. So yeah, basically our next steps would be, first of all, to implement Alto, to see how does it work out in the reality. And we are also interested to see if we have some other things that we can add to the Alto group itself, for instance, metrics that are not available today.
So I've always viewed Alto as a rendezvous protocol, and these various use cases show how interesting it is in that context. Richard, question.
Okay, very good question. Sorry, asking all these questions. And this looks, very beginning looks very similar to like a BitTorrent, right? At the very beginning, you have a tracker, which is your directory service, and then you do all the like tit-for tats, and here you have the propagation transactions, so on, look very similar. And so that looks very interesting. My question would be, for example, I don't know too much about this Bitcoin network. For example, do you anticipate, for example, one initial case would be, for example, in Comcast, in whatever network, you have large number of peers, they do all this stuff. And for your network, do you anticipate they are really highly distributed, very sparsely distributed into different networks? Or you really say, for example, a large number of clients inside a single network? I guess the question I'm asking would be, that would have big implication on where you place the Alto server. You might really need to query a large number of servers, which I guess the question was Sebastian trying to address, or maybe really actually you can only look at the view from a single Alto server might be good enough.
Okay, good question. So in my opinion, there are different kind of possible blockchains. So if we just look for the Bitcoin network, which is the most common use case, I'm not 100% sure if Alto should play a too central role, because I think it should more give kind of a guidance, because in the community probably it is difficult to convince that there's a central entity that gives this guidance. But what I see more interesting is not so much Bitcoin, but more kind of commodity blockchains, meaning we have, for instance, some industry, like some banks that want to collaborate with each other. And there, I think, yes, there might be perfectly distributed, but probably we will not see so many nodes than we see in the Bitcoin network, right?
Right. At least some of the thought
that's a lot on the application.
Some of the thought that's driving this is fintech, but I think Diego, brief.
Yeah, just before you send me back to the seat. No, very briefly, Diego Lopez. There are a couple of activities that are ongoing related to Bitcoins. I don't know if you're aware of. So it would be interesting to have you engage on them. So I can't tell you when is in the IETF.
Are you talking about the Barbov?
Not only the Barbov, there was a BOF as well on the on this interconnection of blockchains. The ledger, you were there, yeah. And then there was this DING thing. No, for the ledger, I think that this could make some sense precisely. And then there is the DING thing that I can't. Well, we can talk about the ledger.
All right.
Actually, we were talking with Stefan and even some days ago in Luxembourg. So.
Sebastian, really brief.
Okay, really quick. Sebastian Kiesel. Maybe I want to rephrase Richard's question again. So the question is whether having a central Alto server that knows everything or having distributed ones has two aspects. One is trust. So do you want your community to rely on a single Alto server which can probably influence your service badly if it gives forcefully wrong guidance? The other is scalability. So how many different administrative domains have to contribute knowledge to this Alto server? Are we talking about like 5 banks somehow hooking up their internal networks, or are we talking about an internet application which runs basically in the whole internet with all the internet service providers on the planet? So I think these are two aspects that should be considered.
Yeah, that's a good point. So I think basically if we consider really public blockchains like the Bitcoin, I think we will not make it with one Alto server. We'll probably have multiple Alto servers that are distributed over the globe. Of course, if we have a much smaller number of like private or community blockchains, I think then maybe one Alto server will be enough. But it's really hard to assess for me right now.
I don't think we have to decide on this right now, but I think there is enough interest that you know, if you do any simulation studies and stuff and you see benefits with Alto in a blockchain network, it'll be nice to come back and present those in the future. Excellent.
Well, thanks.
Thank you. Kim? Or May, right?
Let's look at the badge. This is
Mainland, right?
Good afternoon, all. I'm May, and I'm going to talk about an utilization case of Alto information. That is the traffic optimization for exascale science applications. Next, please. And so the scientific innovation continues to exponentially increase the production of valuable research data, and the exchange of information involves the network infrastructure around the world. So one leading example, which is called LHC, Large Hadron Collider, High Energy Physics Program, which aims to find new particles and interactions in a previously inaccessible range of energies, is a good example. This LHC network has 3 tiers. The tier 0 is the CERN network, and tier 1 is the network between different countries, and tier 2 is the network between different university labs, and the outer range, we don't care. Next. So the scientific collaboration which have built and operate at the LHC, for example, called CMS and Atlas program, have more than 300 petabytes of data under the management at hundreds of sites around the world. And this volume is expected to grow to 1 exabyte till approximately 2018. So the CMS or Atlas may consider a problem of doing the data transfer orchestration. So here we propose this application platform, next, which is called Exascale Dataset Transfer Orchestrator, that is EDTO. So we can see in this framework, there are several key components that are the DTR collector, the dataset transfer manager, scheduler, client, auto client, and servers, and the transfer agents. The DTR scheduler has 3 information sources, that is the dataset information, the DTR status, and the network state. Since we are now in the Alto meeting, so we will concentrate on the network information provided by Alto client. Next, please. So basically, the Alto client will provide information based on RFC 7285, that are the cost map, the endpoint cost servers, and so on. Next. And we know that the Alto will do 1 node topology abstraction, and the client will return an endpoint cost map. So in this example, we can see that by the information returned by the Alto client, the scheduler will make the scheduling decision to allocate the flow rate as 100 megabits per second for each flow. But here is a problem that the 2 flows may share several links, and this may cause some network congestion. Next. So we can see that the efficiency of the scheduler depends on the abstraction level of the topology. Then we may think, how about the Alto client return the raw complete network state? we can know that this will cause extremely high overhead and may cause the violation of network provider's privacy. So here's a problem. Here's a question that how can DTR scheduler get sufficient topology information from Alto server? Next. To solve this problem, we propose a solution called Path Vector Extension Service. In this service, the Alto server will provide topology information of the computed path, and the Alto client will retrieve path vector based on the endpoint cost map, and it will convert the endpoint cost map to graph-based format. Next.
I think Richard is going to go through this in more detail in your.
Yes,
right?
he will talk about more details later.
Yeah. So you want to maybe move to the second use case?
Just
Sure.
30 seconds. So this example will not demonstrate that by using the path vector service, it will return the shared link information of switch 2, switch 3, switch 4. So the scheduler can make the fair allocation decision, scheduling decision to give each flow rate as 50 megabits per second. So this will avoid the network congestion. And next. So we can know that the DTR scheduler receives the sufficient topology information, but it has some limitation that it will bring the redundant topology information, and it will extend the problem scale of DTR scheduler, which may cause overhead, and it may expose privacy of network provider. So the question is, how can DTR scheduler get sufficient yet minimal topology information from Alto server? Here we propose another solution called Routing State Abstraction Extension Service. RSA will provide a lossless compression of topology information of routing paths by using equivalence conditions to achieve equivalent and minimal. The equivalent means that the applications can make the same decision based on RSA response as the path vector does, and the minimal means it will only provide topology information that is absolutely necessary to applications. And we use the same example. In this example, the RSA won't return the details of switch 2, switch 3, switch 4, but it will return an abstract key bottleneck link to represent those several related links. And the scheduler receive this information will make the same scheduling decision as path vector does. Next. So here is the progress and next step. Currently, we have already implemented this platform on a single domain testbed and give some demos on the Supercomputing 15 and the Internet 2 Summit 16. And we have implemented the RSA and will deploy it on the testbed soon. And future challenges here are two. One is that the multi-domain deployment on HC networks, and another is the topology information aggregation from multiple Alto servers. Thanks.
Excellent. Questions? We have time for at least one.
Okay, can I ask a very quick question? And so actually, I'm more interested in the not only Alto aspect.Maybe, for example, what exactly is really interesting and about your scheduling? And can you describe a little bit, for example, why wouldn't the CDN work for this network? And you basically, I think you have tier 0, tier 1, tier 2, and why? So can you describe a little bit? I guess, yeah, very beginning, right. So you have tier 0, tier 1, tier 2. And so what exactly, why this new setting? What exactly are the unique challenges? Unique challenges to do the data transfer.
Yes, because the problem we haven't solved now is the multi-domain transfer.
Multi-domain because they belong to different organizations?
Yes, and it's difficult to define the cost type in different domains.
Okay. Huh. So that's one. One's multi-domain. What else? And do they have, for example, my understanding would be for them, they have the issue of, for example, real-time distribution from tier 0 to tier 1 to tier 2. They have a very, very complicated way of doing real-time distribution because they're doing like real-time detection. Is that right? And is that really some, I guess I'm still trying to understand exactly what are the unique challenges.
Yeah, so we have limited time, so it's a good question. Actually, that's the first question I asked when this was posted on the list. What are the unique challenges? But in the interest of time, thank you for your presentation. We move the discussion to the list. So we move on to the next presentation, which is about cost metrics, right?
Is this the right one?
Oh, not this one.
Not this one?
Yeah, not this one. Also, traffic engineer.
Traffic engineering cost metrics.
Yeah, yeah.
Yes. Right. If you fetch it from there, you get the right one. Yeah. Mm-hmm.
Okay, good afternoon, everyone. My name is Qin Wu, and I will present this draft about the auto traffic engineering cost metric. Actually, we changed the title to auto network performance cost metrics to make it more generic based on discussion on the list. Also, we list here. Next. Actually, this draft is a very old draft, and we started discussing in the last Berlin meeting. So it's taken quite a long time, and that doesn't mean people don't interested in that. We got a lot of discussion, and actually this listed as a chat item, and but we lack progress, and later we consolidated with 2 other drafts, and in IETF 90 meeting, and also as I mentioned, it's a chat item, so we try to fulfill this milestone. And next. So what is we change since the last version? Actually, we revised into the 08 version and to adopt the AFC 6390 template to try to describe the performance cost metrics. And we also changed the title into the auto performance cost metrics because we think we not want to limit to the traffic engineer cases. We want to cover more cases to measure end-to-end and to allow application to connect the peer based on network performance criteria. Also, based on comments from Frank Bragg, we added some IPv6 example. I think this apply many draft, and we actually clarify the metric we target actually is end-to-end rather than hop by hop, and clarifies hop count usage because we in the previous version we have some edit node. We leave that open issue. We try to address the issue and close this issue, and we also clarify the validity of the cost metric that need actually this kind of metric need to be negotiated between the client and server, and this validity of the cost metric may be one or multiple of the measurement interval for the cost metrics. If it is the former case, actually it's actually fixed. If it is multiple measurement interval, actually is candidate, and also we already talked about the auto cost candidate, and it's covered by the previous draft we already discussed. And in addition, we clear the confusion actually on whether we redefine the cost metric or how it relate to the BGPs. And actually, BGPs has already been published as AFC, and it's kind of one data source we use, and we can get the data and aggregate the data, and we can export to the client. And also, we actually don't not redefine the metric. We actually derive this kind of metric. We aggregate the data and try to make to focus on end-to-end and network performance perspective. And next. So what is about this draft? Actually, this draft proposes 11 cost metric, and we have delay, jitter, packet loss, hop count. For bandwidth, we broke down into several other new bandwidth related metrics. I don't want to repeat this. Next. Okay. So why I propose this new cost metric jobs? I think most important motivation is to try to fulfill the charter item about the cost property extension. And another reason, actually, we really want to allow application to connect the peer or endpoint based on some network criteria. For example, delay packet loss. We want to choose a path to the endpoint based on latency. We require. We hope it is low latency, or we hope it's low packet loss, and we can base on that. And also, as I mentioned, BGPLs has already been published as a RFC 7752, and they have auto network API use cases, and right now there's no solution, no approach to address these use cases. So that's why we bring up this kind of job to try to fill the gap and provide a solution to allow the client and server to talk with each other and exchange the network performance metric. So another reason actually is one limitation for the auto-based protocol is they only focus on single root cost. So we want to have more rich cost metric. That's why I propose here.
Let's leave some time for the.
Yeah, so this has been around for a while, and we just looked at the charter again, and of course it's clearly within the scope of the charter, and we do have a milestone for cost extensions. Let me look how it's exactly phrased, so I'm being correct here. We do have a milestone for cost property extensions, and of course this is also what Sabine is working on, and this fits here. So I think this is much more mature than it used to be in the past. I'm the one who always says we need to be careful, reminds the working group that we need to be careful with metrics such as delay, because Alto is not meant for real-time scheduling, and it was not chartered for that. Obviously, with the new Alto use cases, we are allowing much more things that change on lower time scales than it used what we were comfortable before. But anyway, I think this is much more mature, and I think we can ask the working group if they want to move it to working group item. Again, working group item doesn't mean that we are that this is finished and we are sending off these metrics to the ISG. I still think some of these metrics deserve more discussion, but I'm saying as a chair, this is a much more mature document, and the decision the working group needs to make is, does it want to have such a document? And I personally, with my chair hat off, I would say probably yes. So open mic, yeah, any comments, I would say, from the working group? No comments.
Okay, so do you want to take a hum, or should we take it to the list?
I don't know what I'm supposed to make of these no comments. Does that mean everybody is actually agreeing with what I just said, or does it mean people have objections but they don't want to? I don't know.
Sebastian relaying Kai, he asks, do we need some kind of style consistency in the naming of the metrics?
Yeah, again, those are minor things that we can probably discuss if it is a working group item or not. Again, working group item decision means, does the working group want to produce such a document, and is this in principle the right approach? Again, out of the 10 metrics in this document, 2 or 3 I would also like to discuss further, but that is for me independent or orthogonal to the working group item adoption. So Ingmar, please go.
Ingmar Benox. I am kind of confused about going this way, because if you look at what Alto, or what I define as Alto, actually thinks, it's very abstract in terms of how it defines things in the network. And what we're suddenly doing here is we're nailing down specific things about the network that on the one side someone might not want to share, on the other side someone cannot share. So I'm not sure whether it's the right way to actually nail these down as it is proposed.
Well, I mean, I understand what you're saying, but just they are not, by no means these are mandatory, right? I mean, they are all options. They just give the Alto server more ways, and Alto has always claimed that it's very privacy preserving because it gives the Alto server many ways to. It can be very conservative. Yeah, I mean, we are not if we would adopt this, we would not enforce an Alto server to use these metrics by any means, right? That's my answer to your question. I share your concerns, and I know what you're doing with Alto, that these are probably not the metrics you would use. I totally agree. But there are other use cases. For instance, the exascale we just saw, if it's a scientific network and you want to optimize it, people might be much more happy to disclose things, right? So that's all I'm saying. But, yeah.
Okay, Richard, and I do actually want to agree with Yang and so on. I think, for example, lately there's one big discussion would be, so far the only metric we define in the base protocol is routing cost, which is abstract, which is not really. For example, you take a routing cost from
which is intentionally abstract, and now we're discussing if we want to give an Alto server new possibilities.
Right. So basically, I think what I'm most interested, I think there's an email exchange between me and Sebastian about we talk about two types of metrics. One is called type 1, one is called type 2, and it's just like arbitrary name. Type 1 really means somehow there's objective in the sense that really like well defined, and you can really verify. Type 2 really is subjective, really depending on some internal information, very hard to verify. I think this one really is moving toward defining more like type 1, meaning objective 1. So therefore, you can really collect information and algorithm. So probably that's useful. But I do agree as well with this would be may not be suitable in the general settings because Alto was designed to be totally opaque, abstract.
But I think Ingmar's comment is a very good technical comment. But for this process decision we are making right here, the working group item adoption that's orthogonal, right? It's just it's optional new things that we provide. Again, with my chair hat off, I think this is useful for the working group to produce such a document. That doesn't mean I agree with all the metrics in detail and we need further discussion on them. That's my chair hat off personal opinion.
Sabine, really brief.
Okay, so there are two aspects that we will, I think, add to the draft. One is relating to Ingmar's comment. And yes, indeed, Alto has the duty of protecting ISP privacy. That's for sure. This motivates the fact that TE metrics are by no means to be put in an Alto server as they are. And there will be a lot of abstraction and they will be aggregated. So the idea is more
really brief.
What is the Alto server sense with respect to such a metric? Another case that would allow a little bit less of privacy is the appearance of SDN controllers that are used on top by the operator itself just to simplify network management. So they use SDN controllers.
But Sabine, the main question is, do you in general agree that the working group should produce such a document?
Yes. Yeah, okay, that's, I think there's no time for a hum right now. I think what we will do, there's distinct agreement that this is good. We'll take it to the list and post everything there and move from there.
Thank you, Chair.
Richard.
And since we are significantly behind schedule, the longest slots this is now one of the longer slots, so we need to cut time here, Richard.
This slot should have been over in 5 minutes.
Right.
Oh, 5 minutes? Okay, I'll be very good. Okay, please.
This is you want the path vector?
Yeah, path vector, please.
Yes.
Okay, so I'll talk about path vector, and I'm going to try to be really brief or fast. And lucky thing is actually May has already covered some of the slides which I have already. Next slide, please. And so overall, this essentially, if I have only like 1 minute, this is all I'm going to talk about. And essentially what I'm saying would be going beyond single switch topology abstraction, largely agreed upon in the working group and so on. We have discussed about it all the time. We have all the use cases and so on. For example, even like skill science, and which I guess people are doing with Caltech, with CERN, doing all the deployment and so on. And really important is there's a charter item. And the working group, essentially, there are multiple design. This is one of the few cases where we really have a lot of quote unquote competing designs. We have multiple design over here. One's called node link graph design. There's I believe 1 or 2 drafts appeared before. And there's also the node link and path vector design, which I call NLP design. And there's also later this newer one emerged called path vector with abstract network elements design. And there's also ECMP, multiple calls and path complexity and so on. And the proposal, which I'm going to talk about here is, let's really see that can we adopt the AP design, abstract network element design, as a first step to address the network graph charter item. Next slide, please. So do we talk about why this is a good design? Let me just give a little bit background and some frameworks for this. That's convince everyone this is good enough. This is not the most generic one, but it's a good design, a good enough design, so therefore we should move forward. So here's the framework, which actually a lot of people are considering, which I'm interested in as well, and this general case. So for this case, really it's application layer traffic optimization. So what they have is application would have set of flows, K flows, and the path already given. So this is really assumption. if, for example, if we really want to go down the path, for example, Alto would do allow application to control the paths, probably our design would be good. But here I want to convince this working group or the audience would be, and maybe the really good assumption at the very beginning staff would be, let's assume the path already given, so therefore we don't have control of network paths. They're given, and essentially not interactive. And if that's the case, all application can really do is really very simple. They can only control the traffic volume along all their overlay paths. And essentially they're controlling is these parameters called F1x, which x is the traffic volume and so on, and all the K. And all application can do really is and compute all these paths. That's all they can do. So therefore, if that's a setting, do we have a good enough properties or not? Next slide, please. So if that's the case, and essentially this is a use case we talk about all the time, May has shown as well, and this is shown by many people, Greg Bernstein and all the people, and essentially is what we're really doing actually for all the use cases we have to convince about us about network graph is what I call nowadays called capacitive region use case. So for this use case, we have graph, and we have, for example, very simple case, two flows, flow one, S1, I'm sorry, go back. Flow one, S1 to D1, S2 to D2. I want to say, hey, I want to really do my capacitive region. I want some traffic and how much traffic can really send. For example, for the CERN, for the traffic distribution, there are multiple pairs and there are all these flows and so on. Next slide, please. And if we use the current flow, for example, the auto information, essentially what happens is analyzer say, hey, from S1 to D1, S2 to D2, you're going to have essentially 100 for each, for example. And the capacitive region essentially is the square. You always get this information, capacitive region is a square. Next slide, please. But actually, it may not be true, for example. And for the two flows, for example, they might share bottleneck. Therefore, capacitive region is not actually a rectangle, it's not a square. Actually, it can be a triangle because they share bottleneck. So therefore, really sum of the two flows has to be less than or equal to the total capacity, which is 100. And so therefore, this is a real limitation. Next slide, please. And this is another one, for example, suppose you have single path, so therefore also capacitive region will be one. You can all get confused with the current auto information. Next slide, please. So therefore, if we consider, for example, capacitive region as the main driving force, which I believe actually so far that's all we have, and we don't really have other too fancy use cases. For this use case, and as we look at, for example, all the three design options, because we have multiple drafts and competing and so on, and one is network link. That's not good enough information because you don't have the routing, so therefore you don't know. That's not enough information. And if we use network node link graph and with path vector, and actually it's complete, it really can solve the use case and will give you all the capacitive region. And the problem is, it probably gives you too much information. It does not really follow the philosophy of Alto to be really abstract as simple as possible. So therefore, let's look at the last one, which is path vector with epic network elements. That turns out to be the sweet spot. Therefore, I'm proposing that the working group will go down this path to solve the network graph design. Next slide, please. So that's the design. Suppose we all agree, and suppose we all agree. Now, next step, I really convince this working group or convince the audience would be, hey, what are the remaining issues? It turns out that we really encounter a few, actually 3 major design issues. So let me enumerate them very quickly. Number one is somehow actually encoding turns out to be very, very simple. For example, the encoding will be have cost map, and you enumerate all the paths over there. The key issue is what exactly cost metric and cost mode for this cost map? Now, we don't know. Actually, the current base protocol wouldn't specify. They are clearly cost mode. It's not numerical and not, for example, ordinal. So what is it? Next slide, please. And essentially, in higher level stuff, which I want to bring up, the issue why I cannot even convince myself to really decide which one should be working group working item is essentially for both cost map and also for endpoint cost map. Essentially, they are generic types. They are not really, for example, some funny like small things. They are really actually behind it. There's a very, very big important issue is called type system. Right, and well, a lot of people probably here are computer scientists, and for computer science, understanding type system is one of the most important things in programming languages. And here is our architecture cost type. They are generic polymorphic types. How do we link in the types? Next slide, please. Essentially, there are 2 design choices. Let me put it over here, and I want to convince the working group which one to go. And one is introduce specific cost mode and cost metric to indicate this path vector. For example, the cost mode can be path vector, cost type can be hop count. And second one will be unifying cost type scheme and handling multi-cost, cost calendar, and so on. Essentially, I think these are the 2 design choices. One specific, one generic. Which one should we go? And I'm going to give a proposal. I think I probably want to go to the second choice and coordinate with the multi-cost and the cost calendar. But I'm going to put the design choice open on the table. People can discuss. Next one, please. That's not question number 1. And question number 2 in the design, and why we're still somehow delayed for this one is the following. is so far both the cost map and endpoint cost map, they are designed for cross product, which is just fine. They're really designed for cross product. But design instance, you have end sources and you have end destinations. You're asking, hey, what's the cost map? And you're asking for everyone. But such queries can involve a large number of paths. And then with computing abstraction, it turns out to be very inefficient. And so sometimes you really can't very hard to really abstract a very complex topology because you probably need to review a lot of stuff, which you may or may not do. Next slide, please. So essentially, the query is the bigger design issue here is the following: is possibilities make a PV query to be non-cross product. For example, now the query become auto flow parameters, and now you really define the flows and so on. And the proposal would be then you record it with flow cost service, therefore to really do all this type of stuff. So really limit the query precision, not really do generic cross-product query. Next slide, please. So essentially two designs. One is use a native cost map for PIDs and any cost map. A second one would be using flows to really do very precise query precision. And which one should we do? And actually, my proposal, if working group can agree on, would be actually use first one because it's simple and that's good enough. Next slide, please. So next one is essentially actually also important issue. Turns out why this is complicated is the next issue would be design. We have two design choices, and one is how do we really return, because we get the path vector. Now we really know about the properties of path vectors, and now we have two design choices. One is inline, embed in the same cost map. And second one will be use a reference. So which one do we use? Next slide, please. So here is the inline design. We have the path vector over there. We put a inline design over there. Essentially, will be part of the property will be embedded into it. Next slide, please. And second one would be we use dependent, for example, a different map and to really convey all the costs. So that's called the reference. Next slide, please. And here is a summary about how my personal view about how network graph chart item should proceed. And the proposal is we use abstract network element path vector. And among the three design points, I think those are the three design points we have. For the first design point, how do we specify cost type? I really potentially propose we coordinate with, for example, multi-cost and cost calendar to do the cost design together. For the design question number 2, and how do we really, for example, do a precision this moment? We can take an easy way out. We use a native cost map query. For the design number 3, actually more and more, my proud preference will be we use the inline approach because that would be simple, clean, and therefore it's more flexible. But I'm really, I think, really open to the working group. I think I'm done. I don't know if I make it faster.
So in my position again from Benox, basically I have a lot of experience with actually getting the data out of a network into an Alto map. And what you're proposing here is you have mostly link state driven networks that you want to turn into a path vector that people can sort of recalculate the whole network, which means you're turning something that can already do the routing into something else so that they can convert it back into the state that they had before. I personally don't see the need to actually turn this into a path vector, stay at the link level and just augment the individual links. If that's really necessary, people can run the Dijkstra themselves and figure out what's happening in the network.
Okay, so let me clarify. I think that's a great question. Let me clarify. And the design will be able to handle, for example, both path vector, for example, BGP information. That's already path vector, so therefore it's very native mapping, right? And relatively, and because already path vector. And second one would be, I'm assuming even though underlying is link state, for example, OSPF or ISS, and the assumption here is the routing is already given. So therefore, if the routing already given, actually I do have a routing path. Therefore, I'm really calculating. I'm not really, application can only do is in the application overlay routing. Therefore, I really need to tell them a little bit shared links in the underlying routing. Would that be okay or not?
I have to think about it.
Okay. Other comments?
Other comments? Now, Richard, how do you want to do? Do you want to go to FCS or do you want to hold the discussion? What, you have the floor till...
Oh, FCS, I think it would be brilliant by me as well.
Yeah, so I would propose you present do the presentations first, and then we have the general discussion on how they all relate and stuff, right? That we
Because one thing I want to get out, both Jan and I want to get out of this is that, we have a charter deliverable that says a document specifying how a graph representation format can be used in Alto. And we don't have any documents towards that.
We don't.
In any
documents towards.
well,
We have a lot of documents, but
But
we
we-
don't agree on one.
yeah, we need to figure out which one, two, or three are going to go towards that.
That's the point.
That's what I would like to discuss during the open, mic meeting.
Makes sense. So why don't we, for example, I think May is going to present essays, not me.
Okay.
She's going to present and probably be very brief. Can you do very brief? And then I'll come back and then we can do.
She can do
the
brief. She
general
was
discussion.
brief before. Okay.
Yeah.
Yeah. Good.
Okay.
Full cost service.
Yes.
Go ahead.
Okay, I'll be very quick. So the network is introducing the fine-grained routing strategies to allow the application to do more works but sometimes by using the fine-grained routing may cause some ambiguous result by using the ECS query. Here is an example that if we want to query the cost between host 1 and host 3, which cost should we get? The cost from host 1 to switch 1 to switch 3 to host 3, or another flow cost. This is ambiguous. So we propose the flow cost service, and here are more reasons why we should propose flow cost service as below. Next.
Keep going.
Yes, here. And as we mentioned before about the flow correlation, if we query the flow cost of flow 1 and flow 2 together, we can get the flow correlation for switch 5 to switch 6. But if we use the ECS, we may not get the correlation. Also, we may get the redundant information of flow 3 and flow 4. Next. So here we propose this flow cost service to deal with both problems. In this flow cost service design, we use the format of the flow that the flow ID follow the format of the OpenFlow protocol. That the flow ID follows the format of PID name, and the typed header field follows the format of the subset of OpenFlow. Next. And sometimes if the client cannot provide sufficient information to do the query, the cost we get may be inaccurate. So here we propose the cost confidence to show how precise the cost we get is. And this range is from 1 to 100 to show the accuracy of the cost. And next. And we can see that this flow cost service is compatible with our cost types and some potential extensions like multi-cost, calendar, and path vector. Next. And here are some problems we may consider. One is that how can the clients get accurate queries, and how about if the client cannot decide the flow configuration, and how to explore ambiguous paths efficiently to compute the cost confidence.
Thank you for being quick. Because now we are back on track, actually. With
Yeah,
the
and apologies for everybody that we rushed through.
Yeah.
Next time we'll get 2.5 hours. So Richard, why don't you come up and drive the discussion? Again, from the chair's perspective, it'll be nice to get a set of drafts that go towards the graph topology.
Okay, right. So I do want an insight I take actually. Can you show my last slides for the path vector?
For the path vector?
Yeah, path vector, because I think that's probably the most important slide, and that's a decision. Yeah, go back. Oh no, yeah, here it is. Right. So I do want to, even for people actually who have not read, for example, this document, algebraic document, and for people who are doing networking, it's in the path vector, link state. They are fundamental concept, which I presume everyone would have sense. And so therefore, here I really want to get a sense and also get everyone who knows about this involved would be what's the design decision point. For example, for Alto in application layer, what is good network graph design point? And here the proposal really is path vector, because essentially we assume routing already given. So therefore, you probably really should give a path vector because routing already given. You don't really have link state. And is that really the way we want to proceed or not? I think that's probably number one thing we want to discuss. Of course, here is important part is we're not going to use native network nodes and links. We're going to use abstract. We're not going to distinguish they are links or nodes. We want to say, hey, they're just abstract network elements. No comments? Okay.
So again, maybe I read what we have in the charter, right? So the charter says we have a charter item for a document specifying how a graph representation format, blah, 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 can be used in Alto, right? And potentially exported by an Alto server. So all of the proposals are going towards that, but as Vijay said, we as chairs, but I think the working group feels the same. We would like to have an overview. How do they relate? Do we want all of them? Do we want to choose one of them? I think they're all addressing different use cases, so they're not competing with each other, right, Richard? So that's not the case. But the question is, so for yeah, maybe Vijay. Go ahead.
No, I'll just read.
Sebastian, relaying a question from Greg. Would we consider the SDN virtualization case? In that situation, the routing wouldn't be given, but the client would make a path choice.
Okay. If that's the case, and I think that's a great question. If that's the case, the abstract path element, path vector will not solve that case. For that case, we really need to convey the essentially node link graph. For that case, it's not. I agree.
So this is Vijay Gravani as an individual. I think the path vector work here is, definitely of interest, at least to me as an individual. I think it moves us beyond what you've been calling the one computer or the one switch view to something that is much more fundamentally in graph theory, where you can figure out the paths and the costs. It fits well with what we have, the current abstractions we have in Alto.
Right. Essentially, they're just cost maps.
Right. Yeah. So, I think it's good work, and I think we should move it forward towards at least some way to fulfill what we have as a graph representation format deliverable.
Great. Yeah. So of course, go ahead, Sabi. Go ahead.
Yes, so I think it is also useful and needed to go deeper, have a deeper insight into the one switch path. And so there are use cases here that brought either by SDN, but also by cases such as CRAN, for example.
Okay.
If you want to represent an end-to-end path of a CRAN, or of
it's very complicated.
Yes, exactly. You need to have sometimes you neither care or have the rights as a third party, as a tenant, to see how this path is structured, but you need to have a clue on the difficulties, the bottlenecks, or some things. And I think there has been recent work on unified scheme to name those elements, and also topology,
right.
Zooming, local zooming, and again, it's not the absolute topology.
Okay.
So I think, yes, we should be able to, well, not only in that path, in that detailed path vector, we should be able to integrate hops, but that represent heterogeneous elements, not saying this is a switch, this is a wireless node, but just to say, okay, here are some abstracted properties.
Okay, let me give two. Oh, can I respond very quickly? And one would be following. Actually, by the way, I think there are two comments. One would be related with Greg's comment. Even though we go down the path of abstract network element, we're not going down the possibility that we cannot really distinguish, for example, nodes and links. For example, one thing we can do is for each abstract network element, we can indicate its type. For example, this is a node, this is a link, this is a CRAM, this is AP, and so on. Actually, we eventually we can get an attribute to indicate, but it's a moment we say, hey, we don't care, we don't do that. And so therefore, we are not really, for example, go to a pothole, we're just stuck over there. We can still actually can recover. That's number one. And number two, very quickly comment would be following. I think that's related with Greg's comment would be, if you really follow SDN routing use case, there's a lot of work in IETF, for example, talking about, for example, topologies from A2RS, from all these guys. And maybe that's a case where other people, we can use other people topology, we can just import into our system. And this is essentially more unique. So therefore, that's my response. Go ahead.
So Sebastian, again, relaying Greg. He asks, should we have a problem statement and or an architecture document that enumerates use cases and solutions and then separate solution drafts?
So let me clarify. And so Greg, I'm presuming you can of course hear me. So your thing is, you want a document to architecture essentially, I guess, a probably not too long architecture use case document for graph use cases. Okay. So basically we're talking about two documents.
Right. Two documents, I guess, is from the working group chair's perspective not a problem, right?
Yeah. The bigger problem to me, is, we have path vector, we have flow service. What is the intersection between them? Can path vector support what May just described? Or is that completely orthogonal that we are going to have yet another deliverable with flow, flow service?
My understanding would be they are orthogonal, and the flow service essentially trying to go down the issue number 2 and would allow more precision in terms of query. And path vector more on the encoding of the return results. So one is query, one's response. They actually can be orthogonal. They can be combined and to have a much more powerful scheme.
So flow service can be as an additional Alto service?
Can be an additional Alto service.
While path vector remains the representation format.
Additional of the result. Can be both from the flow query or can come from standard, for example, native cost query.
I have another question. So from my perspective, but maybe you can comment, the path vector is much more non-real time as the original Alto charter, whereas the flow cost service is more something that will be queried more often, right? Or
potentially, because that's a more fine grain.
Right. So that doesn't mean I have anything against the flow cost service, but from a Alto, what Alto was originally chartered to be, the path vector seems to be much more in line to me with that, because it's something that doesn't change so instantaneously, where flows change obviously instantaneously.
Sure. Yeah.
And then you have this problem of how many of those are you going to have? How are there going to be feedback loops and all this stuff? So all I'm saying is that, so I still think it's very interesting, but the path vector seems to me much more a generic concept that is not so fine-grained, not super fine-grained, and also doesn't change so often, right?
Right, because abstraction and potential little hope is they don't change very often. Therefore, one potential pathway go down would be path vector plus native cost map, without really go to the flow query.
So can you advise the working group if there's any other documents that you're aware of, because you have been playing in this area, that come close to what path vector is doing that might be alternatives to graph representation?
Not really. And of course, we really have BGP, but of course, we don't want to use BGP. That's really too fine grained all the details. We want an abstract level.
So repeat, as you were saying that you could combine path vector and routing state abstraction. Is that because it's two documents?
Yes, we can combine path vector with a native cost map query.
Okay.
And then of course, the remaining issue is inline or reference. We probably can. I probably would be happy with, for example, inline, which is very simple. Of course, the implication is we probably eventually then would really need, for example, a auto cost map version 2.
So maybe the working group can comment, but right. So for me, it seems that we kind of agree on path vector and routing state abstraction to move forward towards the chartered item. And the flow cost service is more a new advanced thing that deserves further discussion. And we need to see, I personally also fear that there we would get some criticism from the ISG, but maybe I'm wrong. I don't know. But, you know, because of the things I just said, because it seems to me too real time, too, you know.
Potentially can be the real time.
Right. Also, when people talk about SDN, you know, many people confuse SDN and think, I'm just giving another example where people think the SDN controller can control every flow in the whole network in real time, and that's probably not what an SDN controller can do, right? And here you have the same, right? So you have these problems everywhere. Anyway, so Vijay, you agree, right? So the question to the working group is, do they see it the same way? And do we? I mean, it seems to be that then these first two documents, path vector routing state abstraction, are going towards our chartered item. Whereas flow cost service, we keep in the on the queue for further discussion, right?
And this is important. It'll be great to have some input from the working group on whether these two, you know, go towards the charter. Maybe you want. I'll put the charter up also. Yeah. So please don't hesitate to come up to the mic.
Yeah. Any other comments? Important and interesting.
Well, yeah, but from a process perspective, it's always like this charter has been around for a long time, right? The new Alto charter, and we've heard many presentations from you, Richard, and those are basically the proposals we have on the table now. So it's also now the time maybe to move forward, which is the one the working group wants to choose. So. I don't. Again, working group item, for instance, that means that we think this is the one to go. And currently, I don't see many other competitors for this one. Also, right? Apart from what you are proposing, Richard, and you just agreed that the flow cost service is probably more advanced stuff, and right. So
flow cost service and also network link graph. I'm involved, and I personally feel this is the simplest possible one.
Some implementer perspective, yes, please.
Lyle Burtz. So I think part of the struggle or lack of energy here, right, is we know and working with Alto, I know I need graph representation. I want to be able to use other graph algorithms. Some things that Sabine and I have talked about really are amenable to graph metrics. And so we definitely agree with the working item. It's still something that we have to do in the charter. I think my lack of energy centers around the fact there are no other compelling alternatives. There's a lot of work to do.
Okay.
In general. And I think, you know, most of us, especially as operators, are used to the much lower link state and everything else. And so there is some reluctance to kind of give up, if you will, and go into something like PV. Okay. But in general, I would say I support it. I think it's what we have.
Okay.
Right, and again, we're at the state of the working group where we have to see what do we have, what are the alternatives, and we need to make a decision. So that's the kind of comments we are looking for. Exactly.
Yeah, so I'd say at this point, I don't see anything else compelling. I'm okay with it. I'll have to give up some things. I'm used to this maniacal control of my network, but this is Alto, so I'm all for it. Let's go for it.
Great. Good. I think in the interest of time, we cut the discussion now. I think for me, this was very fruitful.
We have 3 more minutes.
Yeah, right. But we also have 2 more presentations that maybe if they have.
We have 3 more minutes if we were to stick to the original schedule.
Right.
So if anybody has anything else to say, by all means, come and avail yourself of the 3 minutes since we kicked many people off early.
By the way, I forgot actually my whole presentation. I do have like a different set of presentation for this part.
But this is important. Sabine, could you please reflect in the minutes that, you know, the routing state abstraction and the path vector could be 2 possible drafts that go towards the deliverable that is visible up there on a graph representation format. We will take it to the list, and then, you know, we can move from there once it's ratified on the list.
Great. Sounds good.
There is time. I really like those. The path vector and also I would say the flow cost service. Those 2 concepts open the door to something we already discussed a couple of meetings ago, which is to provide costs not only with respect to time or quantitative consideration, but also with respect to qualitative. And actually, so for example, the flow cost and maybe the path vector is, okay, the cost under this condition is that value. But in another condition, the same path has another value. And I really see here, if we combine smartly the flow cost and routing state abstraction and path vector,
that'd be really
I see
powerful.
a way towards that, having a solution to this requirement.
Sure, that'd be really powerful, but also actually, I can foresee it will be more complicated, a lot more complicated than we can get done very quickly.
Excellent. I think I can sleep better now that we know network graph representation format has a couple of drafts. Great. So Sebastian.
I think those are yeah.
Yep. So hi, this is Sebastian presenting joint work with Martin about the discovery. So we are still with the use case that we have a rather sparse population of clients in many, many different administrative domains. So maybe the original BitTorrent use case, but also what we hear today about blockchain would be something that goes beyond only, say, 2 ISPs and 1 CDN hooked up together, but internet scale operations. Since the last time I presented this, the draft itself didn't change too much. There was little change, but we asked several people to review it, and basically I'm presenting the outcome. So due to the time constraints, I only brought 2 slides today, 2.5. First slide is what it does, just a short recap. We have an algorithm which gets an IP address as a parameter and returns a URI. The URI of an information resource directory of an Alto server. What the algorithm does is it looks in the ARPA tree of the DNS for Alto specific NetApp records. So it's not a really wonderful solution, but after considering lots of design alternatives, I think it's the best we can do. Talked about operators, nobody's really happy about it, but it seems to be doable. This algorithm is a straightforward adoption of the GeoPriv list discovery algorithm. So we also did what our charter said. We didn't come up with a completely new generic discovery solution, but adopted an existing algorithm to our needs. We do have a prototype implementation, and several people have reviewed this draft lately, and the feedback, by the way, thanks to the reviewers, the feedback about, say, the algorithmic part of the algorithm of the draft was that it's clearly specified. Everybody said it's. I understand how the algorithm is supposed to work. So I think we're clear on that side. But the next slide, please, is how to use this algorithm in the context of Alto. So the intended semantics of this is that those people, so an internet service provider, an IT department of a large company, who control the reverse DNS for a given IP address or a prefix X, they can publish in their DNS. If you want to optimize the traffic from or to that IP address X, please query the Alto server with the IRD URI that was returned when you call the XDOM disk algorithm with IP address X as a parameter. And so that's more explicit than just assuming that if we discover an Alto server by a DHCP, we probably find a nearby Alto server, and maybe this nearby server has the best knowledge about that kind of guidance a node needs. But this way it's more explicit. If you want to optimize from or to X, please call XDOM disk with X and then ask the server. And this is also important, in particular, if you are talking about having a resource directory, so a BitTorrent tracker or this entry node from the blockchain we saw today. So we have an entity in some kind of a signaling plane, which is far away from the actual endpoint. So we want to optimize the traffic from or to the endpoint, but the decision is made at a different place in the internet. So we need to query cross domains, and that's also the name of the algorithm. So with this explicit giving the parameter to the algorithm, we can query cross-domain boundaries. As I said, the draft didn't change in its wording so much since I last presented this, but we had lots of discussions on the mailing list. I think we now pretty well understood how this algorithm interacts with two important Alto services. It's the endpoint property service and the endpoint cost service. I think I still need to update the draft based on the questions of the reviewers. Basically, it will not, the function will not change or the specification, but there will be more text explaining why this is being done like it's written there. So it's maybe not completely clear, but at least on the mailing list, we have now an idea how these two important services should work together with X-domain discovery. For other Alto services, we are still not so clear. Partially it's work in progress, partially it just can be done. So another item would be to expand in the draft why some services just cannot work like this. In particular, if we have a not so well-defined metric like routing cost metric and only sparse populated maps, merging the results we receive from several Alto servers into one map probably will never work, but that's to be documented. But still, if we have this use case with these sparsely but widely distributed nodes using the endpoint cost service, is maybe the best thing we can do. And we now have a common understanding how this should work together with this mechanism. So next slide, please. That's basically all I wanted to say today. So as I said, algorithm is stable and specified clearly, and we have now an idea why this is useful. So I would like the chairs to ask whether we should adopt this as a working group item towards the alternate discovery item.
Yes, so the chairs, we discussed this and we agree. So I asked this on the mailing list already that we should start the discussion. So we think this is the only option we have currently on the table for that charter item. There has been a discussion recently on the mailing list. It has been around, and you just mentioned also, Sebastian, as well understood. So we would like to take a hum. Are there any comments before we take a hum? Any last comments?
Can I ask, actually, because this issue, of course, really is, I guess the main issue here is whoever controls this mechanism will control the traffic, right? And for example, I remember at the very beginning, I had a strong concern from AT&T or from Incentive early days. I think there's on the record, they talk about they want to control all their clients and all their clients and so on, really delicate and control all the traffic. So this probably very important aspect would be from ISP. I don't know if Lyle wants to give comments from Spring or not. But otherwise, I think I want to emphasize this is a very important, powerful mechanism. Just probably that's important to.
Yeah, maybe that's also very common to document in the security considerations of the document, right? Yeah, but as an this is an alternative way. So yeah. So if there are no any other comments, we take a hum now, right? So I'm asking the working group who is in favor of adopting this draft as a working group item. Please hum now. Who is against adopting this? Please hum now. So there was consensus. I mean, it was nobody was against it, and there was clearly people humming in favor of it. And anything from the Java?
From Java, there are 3 hums support.
Okay. So I think that's pretty clear. So
I'm sorry, 4.
4.
I don't know how to count.
Yeah. So that's clear consensus, I guess. So we clear consensus. So this has been adopted. So Sebastian, please issue a new version. And yeah. So I guess we move on to the last presentation.
So again, thanks to all the reviewers.
Right. Thanks to the reviewers for progressing this way. Yes. So last presentation is from Hans on some actual experiences with using Alto, which of course is very interesting for us. Please go.
So,
yeah.
Thanks for squeezing us in. Yeah, so we are actually working with Alto in a live network. So next slide, please. So the scenario, we are actually operating as a CDN that wants to deliver content to our ISP's customers. In this scenario, we only consider passes from the CDN caches towards the customers of interest. So the opposite path is not of our interest because the main traffic simply flows from the CDN towards us. The CDN caches are not only embedded in the AS of the CDN itself, but it can also be inserted in foreign ASs, including our own. So the question now we had is how to group these prefixes, again, how to create these maps. Next slide, please.
So here we see some facts about the network. We operate from a large ISP network with a lot of routers and IP prefixes. I will not go into every detail here because you can see that very well, I guess. So what is worth mentioning is that we also have running an ingress point detection simply to get to know where the prefixes from the CDN or where the flows from the CDN enters our networks. So in this ingress point detection, we detected more than 20,000 prefixes spread across more than 950 ingress points. This covers roughly 30% actually of the whole IP address space and 45% of the public IP, around about 45% of the public IP address space. And yeah, as a fact, we have at the moment a live running Alto server providing guidance for a CDN. At the moment, we are in the test phase, but are aiming to put it productive soon. Next slide, please. So for our network map, we define 3 different PIDs. The internal is for like all IS internal prefixes. The external prefixes, external PID for all external prefixes. And one special type of PID called OnNet for prefixes from the CDN, which are entering our network from a directly peered IS, which belongs to the CDN. The second condition is there should be there is no third-party traffic on the peering link, but only traffic from the CDN. And yeah, we specifically specify the AS number by ourselves. So we just configured the CDN AS number to be from which prefixes should be OnNet. As a second note, external and OnNet prefixes are provided by this ingress point detection. So yeah, ingress point detection basically is a tool we have that detects ingress point of external prefixes based on flow informations. We skip that part, so next, please. For our cost maps, we provided 3 different cost maps, or we provide. The first one is simply host maps, which are the number of hops to the AS, number of hops in our internal AS, or in our own AS. So once we leave the AS, it's simply just one more hop. Then we have pass weight, which is just the cost according to the routing protocols. And the last one is our own custom home route metric derived from delay and peering link utilization. The cost calculation was already presented at IETF 93, so I will just address it briefly. Costs are of course calculated by PIDs. We have a tiebreaker to solve, for example, equal cost multipasses. OnNet PIDs are handled like internal PIDs, so we do not consider the peering link utilization. And yeah, as already stated, outbound traffic is not considered, so we do not taking pass combinations into account where the traffic leaves our network or transits our network. Next, please. So here we have some statistics of our running server. We update it every 5 minutes at the moment. We took,
Update, you mean provisioning, right? What comes into the Alto server?
No, that's faster. So our network maps and cost maps are updated every 5 minutes.
Okay.
Actually.
Okay.
For the statistics we took is a sample of 7 days, which are more than 2,000 samples. In our network map, we have more than 250,000 prefixes across 1,700 PIDs, which are distributed as you see there. The average map sizes we now got is around about 6 megabytes or 1 megabyte compressed. We also utilize the SSA, server send event function, where patch is around about 1.7 for the network map, which is 1/4 of the actual network map. So it's quite worth using patches here. For the cost maps, for the example of our custom metric, we have more than 1.3 million PID pairs with an average size of the network map for 47 megabytes or 5.6 compressed. And the patches itself are around about an average 37.5 megabytes. So here you can see that the patches are not so much smaller than the map actually. It's basically because ingress traffic itself and the utilization of the ingress point is highly volatile. So we have a lot of changes all across the time.
So you're saying you cannot store the map on the floppy disk, right?
That's impossible.
Okay.
A CD would work. Yeah. So there we also analyze the prefix changes between the maps. The red line is only considering internal prefixes. So there we have around about 10 between 2 maps. And for external prefixes, we have on an average like 1,000 changes. This is because of our ingress point detection. It is statistically, so it changes over time. And prefixes are added or simply removed from our network map. Next slide. So while we are working on this specific scenario, we had some problems because of the large network. Our map calculations were running rather long. And since we first need to calculate the network map before we can calculate the cost maps, we had the network map already ready before the new cost map was published. This led to sort of data inconsistencies, and now there's a version tag, but we always have a network map but an old cost map available. So the solution here to just publish all is we simply publish all at the same time. So when the last cost map is calculated successfully, you just say, so now we publish all of them and not first the network map and then the cost maps. We also had some limitations or faced some limitations because the RFC states that the source and destination of endpoint cost requests must be IP addresses, for example, /32 for IPv4, 128 for IPv6. But however, if we want to get costs for certain regions, we we rather need prefixes, simple IPs, because we do not want to provide every IP for like every client, but we want to provide client subnets. And also the empty source and destination field, which is also demanded by the RFC. So when a source or destination field is empty, it will simply be replaced by the sender IP address. This is not suitable for an ISP CDN scenario because usually the CDN is requesting or is sending the request to the Alto server. And if this IP would be replaced with the CDN IP, for example, which comes from the CDN DNS server, so we would optimize or we would send the costs towards the DNS server. But we actually want, for example, the client prefixes. So a CDN can simply say, in a request, we put as source our servers, our server prefixes, and leave the sources empty, and our own server can simply replace the empty empty field with client prefixes. Next slide. So yeah, what we simply did was to our Alto servers that our ECS supports prefixes as well. So I already said empty source destination fields are not filled with sender address, but we let the server choose what to insert there. We also added some timestamps in TTL to the meter field simply to know when a map was created and how long we expect to let it live. And last point, we also added an on-net meter field to ECS and filter cost map requests to let clients provide the on-net AS number instead of that we simply configure it in our own net. So next slide. And that's it. Thank you. Any questions?
I think this is really, really cool. And very few people can go to the last slide. And for example, for the prefix supporting ECS, and do you plan to submit as modification to ECS or not? Because that's very interesting.
I haven't had the time yet, but I actually can work on that, sure.
Okay, yeah, because that's very cool. And for the second one, empty source, probably that's an issue which probably means the Alto client really shouldn't make it empty anyway. I don't think we should, that's an issue that we should fix. Do you agree or disagree?
I think it makes sense to leave a field empty, but I think we let the server choose what to insert and not simply saying that it's the server address or the sender address. So it's cool because in our scenario, the CDN must not, is, for example, is not aware of all the client prefixes. Then it simply says, okay, here are our servers, give me the cost towards the client prefixes, and the server will just fill in the gap with the client prefixes because our Alto server is in the ISP network and is aware of the client prefixes.
Okay, good. And
so, it makes sense to me to have this option in.
Good. The third one, very quick. I think that's also very, very interesting. And I think the original design to don't have timestamp and TTL was because supposedly HTTP should provide it. HTTP should provide, for example, timestamp and TTL, supposedly auto response will be embedded into HTTP. But I guess the reason your rationale to add these two response meta fields would be make the whole information to be self-contained. A little bit like, for example, like a UDP packet wouldn't input IP header, but actually you do like, for example, pseudo header to putting stuff into it. Is that really the incentive to do that for the timestamps and TTL? Because supposedly HTTP would provide them already.
So to
HTTP response.
To put it in the HTTP or?
Right, suppose HTTP response would have timestamp and TTL, right? Roughly, they can do that.
Okay, yeah, sure, it's a solution, yeah.
Yeah, but I guess the reason you do this one would be making, for example, self-contained and so for caching and so on be more works better.
So actually, we also store this content just to follow it. And then we just saw the JSON object and not the whole HTTP.
Okay.
And so we simply
Everything
have it in our map. So let's say we have it in one place.
Good. Yeah, that's interesting addition because from RC 70 to 85, and even in these two fields, I think by the standard, they could be ignored by the client who don't understand. For those who understand, they're going to catch these two results, which can be useful. Is that right?
Say again.
For example, because these two fields will be not unknown fields in the response.
Yeah.
And by definition, the server should the client should just ignore them if they don't understand.
Yes.
But you're going to send these two information by default, right?
Yes.
Okay.
So thank you very much. Unfortunately, we're running over time, but we are happy that we finished all the presentations.
Thank you.
Yeah, we're happy to have you, Hans and Ingmar. You're always welcome in our session because this is a great deployment of RFC 7 to 85. So we are happy to have you, and thanks for this feedback. I mean, you're actually giving us concrete feedback of an actual large scale deployment on, what the protocol needs to, in the future version maybe needs to fix. So that's very valuable to us. Thank you very much, everybody. Any last words, Vijay?
No, just apologies for people who could not get enough time. We'll try to rectify it the next time by getting 2.5 hour slots.
Right. So we need a larger slot, but I think we made a fair compromise for everybody. Our goal is always that everybody can present, and I think we achieved that. So have a great week, rest of the week, and see you next ITF meeting or sometime again.
Yes.
I think it was a very good session. I think we got it resolved because